Welcome to Prism Technologies. I am Venkat. This is part 64 of SQL Server video series. In this video, we'll discuss about replacing cursors using joins. In part 63, we have discussed about cursors. The example in part 63 took around 43 seconds on my machine to complete. If you haven't watched part 63, I would strongly encourage you to do so before proceeding with this session. In this video, we'll discuss about rewriting the same example using a join. So if you remember, in part 63, we updated the unit price in TBL product sales table to 55 when the product name is product 55. If the product name is product-65, then we updated the unit price to 65. On the other hand, if the product name starts with product-100, we changed or we updated the unit price to 1000. Let's see how to achieve the same thing using joins and see how fast that query will be. So what do we want to do? We want to update TBL product sales table. Within that, we want to update unit price. So set unit price is equal to, I'm going to use the case statement, but we'll come to that in just a bit. First, let's specify the tables. So in the from class, we specify product sales table. So I want to update TBL product sales, and I'm saying from TBL's product sales. And to find out the name is not present in TBL product sales table. It's present in TBL products table. So I have to join with TBL products table and specify the join condition. What is the common column between the two tables? In TBL products, the column is ID, and within TBL product sales, it's product ID. So that's the common column between these two tables based on which we are joining them. And look at this. So what do I want to do? I want to update the unit price to, so I'm going to use a case statement here. So case when name of the product is equal to, okay, let's copy it from the cursors query. So if the name is product 55, then what we want to do, then we want to update the unit price to 55. Along the same lines, if the product name is 65, then we want to update the unit price to 65. And along the same lines, when name, like if it starts with product-100, then we want to set the unit price to 1000. Okay, so that's our condition, and then we basically want to end the case statement. Okay, so it's a very simple case statement. We have discussed about case statements in the previous session of this video series. If you haven't watched that, I would strongly encourage you to do so. Okay, so we have that there, and in the where clause we can specify what products we want to update. Since we now have access to the name column as we are using a join, we can also filter the rows. We don't want to retrieve all the 600,000 rows from TBL product sales table. We can filter them using the where clause. So I'm going to specify where name is equal to product-55, or let me copy that, or where name name is equal to product 65, or finally name like product-100. Okay, so whatever rows matches these criteria, retrieve them and update their unit price to 55 if the product name is product-55, or 65 depending on these conditions. So let's go ahead and run this query and see how long is that going to take. Now remember, in the previous session it took around 43 seconds to update to process the rows on a row by row basis using cursors. Let me execute this now. Look at this executing query. It took around 2 seconds, and how many rows are updated? 1694 rows are updated. Now to check our results, we can make use of the same query that used in the previous session. So when I execute this query, we should get all the rows, and look at that, whatever has 100 name pattern product-100, and then anything after that, the unit price is updated to 1000. Let's check it for product 55 and 65. Press F5. Look at that, product 55, all of them are updated to 55, and 65s are updated to 65. Okay, so the update query worked as expected, and look at this, the amount of performance varies 2 seconds and varies 43 seconds. There is a drastic improvement in performance, and that is because we are using joins. That's one thing. Joins work much better because they operate on rows on a set basis. Okay, whatever rows meet this criteria, they are updated, in sets rather than processing the rows individually on a row by row basis. And another thing is, since we are using the where clause, we are not retrieving 600,000 rows from TBL product sales. Instead, whatever rows matches, whatever are the common rows between these two tables, and then we also have a where clause, so it reduces the rows to 1694. That's why this query is very fast. Okay, we can even remove this where clause. So if we remove this where clause, then what's going to happen? We get 600,000 records. Okay, but still, since we are using a join, it's going to be very fast. So but then if I remove this where clause, then what's going to happen? We get 600,000 matching rows. So if we get 600,000 matching rows, look at this. You're saying set name unit price to 55 and name matches to product 55, otherwise 65, otherwise 1000. If the name of the product doesn't match to any of these rows, okay, then the unit price will be updated to null, and we want to avoid that, because since we don't use this, we get other, if we are not using this where clause, we get the other rows as well. And if the name is not matching any of these three things, then we don't want the unit price to be updated to null. That's why what you do is have an else class. If the name doesn't match any of these three, then what I want back the unit price. Just update with whatever unit price that's already there. Okay, but usually we don't do this because we already have access to the name column as we are joining these two tables. You can simply filter the rows. But even if we don't filter, even if we are processing all the 600,000 rows, and I'm doing that using a join, let us see how long is this query going to take. Okay, now when we execute this update query, it's going to update 600,000 records, because in TBL product sales we have 600,000 records, and there is a matching row for every row in TBL product sales. A matching row is present in TBL products. That's why this is going to update 600,000 rows. Now let me go ahead and run this. Look at this executing query. Now it's definitely going to be more than 2 seconds. Remember, the previous query using cursors took 43 seconds, but look at this query completed successfully, and how long it took? 6 seconds. And how many rows has this affected? 600,000 rows. Okay, though it's processing 600,000 rows, we still have the data processed in 6 seconds. But whereas when we do it with cursors using a row by row, when we are processing rows on a row by row basis, it took around 43 seconds. Okay, now let's quickly check if the data has been updated as we expect. Okay, so first I want to see for product 55 and product 65. So that's the same 55 and 65. And let's check for the other things where name pattern is product dash 100. So that's 1000. And let's check anything that doesn't match these things, because we don't want that to be updated to null. So let me select top 10 star. Look at this. For the other products, the unit prices are the same. They were not updated to null. Now whenever you don't have the where clause, make sure you have this else part. Otherwise, what's going to happen, if that condition is not matching, look at what's going to happen. If I execute this update query, some of the rows will not match these conditions. For all those rows, the unit price will become null, because none of these conditions are met. So a null will be returned and unit price will be updated to null. All these rows will work as expected. For 55, they will be, let's for any product with product dash 100, that's okay. And for product 55 and product dash 65 also, it will be fine. The data will be fine. But check top 10 maybe from a product sales table, check the unit price, it will be null, and we don't want that to be happening. That's why whenever you use a case statement, and if you are expecting rows that may not meet this criteria, and if you want the data to be updated correctly, make sure you have your else part as well within the case statement. So when I execute this query, obviously you have seen that there is a drastic improvement in performance. Okay, so this can, you can imagine the amount of impact that cursors is having on performance. Cursor should always be used as a last option. If you don't have any other way of achieving what you want to achieve, only then make use of cursors. Or if it's a throwaway script, you just want to run it one time, and if performance is really not a concern, maybe we can make use of cursors. But real-time production code, we know how bad cursors are for performance, though, so they should be avoided as much as we can. On this slide, you can find resources for ASP.NET, C# and SQL Server interview questions. That's it for today. Thank you for listening. Have a great